Hi everyone, my name is Abel Gray Cantoma. I'm from GREYTEST Card Design Concept. This is actually my WhatsApp contact. You can reach me on this number or you can call me, okay? These are the list of some of the softwares which we have covered on our YouTube channel. All of these softwares are very much available on our Telegram platform. We'll guide you on how to install them and how to crack them on your system yourself, okay? So you can see these are some of the softwares listed here. Okay, today I'll be taking you through the design of a 10-story building. Okay, I'll be taking you through that process, okay, where we are going to be using pile foundation for that, and then on our core wall, okay, we are going to actually be using a raft, okay, like a mat. Okay, right now let's jump right into it. This is our Protastructure. Okay, I'm going to click on new project. I'm going to name this 10-story. Okay, use underscore if you want to space. Okay, good. Now click on OK. I'm going to use this template BS8110. I will import. Okay, I have done a lot of tutorials on architectural working drawings, structural designs and detailing, road designs, water designs, okay, mechanical and electrical service drawings are just very much available on this YouTube channel. All you need to do is just to go down below the description of this video. You will find the link to that channel. Go visit the channel and actually keep yourself busy. We train people on our Telegram platform where we'll give you the software, we'll guide you on how to install it and how to crack it on your system yourself. Okay, we are going to take you through the whole process of design on each of the softwares, all of these softwares, okay, for a token of 12,000 naira. Okay, all of this software is very much available. We'll give you the software and guide you on how to install it, and then we'll train you on each of this software. If you just want to go for one software for 3,500 naira, for 3,500 for 40 days. Okay, amazing, right? Now the first thing we're going to do right now is to we are going to actually import from our external reference drawing. Okay, so I already have an AutoCAD file which I have actually saved as a DXF file, but I'm still going to show you that briefly before we continue here. Now in order to do this, all you need to do is just to go to open your file. It's actually loading. It's actually loading too as well. Okay, click on OK. Now okay, here you can see this is actually my AutoCAD file. Sorry, let me open this. Let me open this. Okay, good. Now you can see this is actually the file I actually converted to a DXF file. Now let's come back to our Protastructure. I'm going to import member because I don't want to actually begin to insert my grids. Okay, so it's going to import it with the grids on. It's going to maintain the grid and the column points, okay, and the columns for me from my general arrangement in my AutoCAD environment is going to maintain all of these columns for me. Okay, so one thing I must actually take note of is you can see all my columns are actually in a layer. So you can see this is detail hash, that is the name of this layer. Okay, but I want to actually change all of these columns to another layer, which I'm going to name them all of these columns. All of my columns. Sorry, let me just do something sharply. So I'm going to isolate just this. Okay, so all of these. Go to property. Now I'm going to actually change this to a column layer. Okay, so I'll go look for my column. Go look at my column here. Okay, so I'm going to turn on my layers back. So if I click on this column, good, you can see it has switched to column layers. Now my grids, okay, so this is actually for horizontal. So let's see for vertical. Okay, so they are both grids. Okay, so my horizontal and vertical grids are all named grid. Okay, so I'm going to import member, import axis. Okay, so I'll click on OK. Okay, so I'll go down here. You can see there's number of errors. We don't have any error on this, so it's actually very much okay. So I'll close this and I'll close this. Good. Now this is our diagram. Good. This is my general arrangement. Okay, sorry. I have to import this again. Okay, because I have made some little adjustment on this, so I'm going to save this as DXF. Yes, and then I'll close this. No, I don't want to save it in AutoCAD format. Okay, good. Now come back here. Let me load again to open. Okay, it's actually loading. If you already love what you're seeing, make sure you like this video, give it a thumbs up, subscribe to this channel. Just look for that red button written subscribe, click on that red button and you have subscribed already. Okay, click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, to encourage as many that wants to have a deeper insight of design. Okay, it's actually still loading. Okay, so we have to allow that to finish loading. Okay, good. Click on OK. Aha, now you can see my columns. Okay, sorry, I will have to take this because of the changes I've actually made on the software on a DXF file I'm actually trying to import. Okay, so I'm going to take that again. I'm going to reopen this file. Okay, I have actually covered a very wide range of tutorial as regards to Protastructure, okay, which is very much available on my YouTube channel. All you need to do is just to visit that channel and actually keep yourself busy. Okay, so I'm going to take this part again. Okay, I click on new. I name this 10 story, for example. This is just a name. Okay, okay, good. I'm going to use this template BS8110. You can actually use any of this code of practice. Okay, they are all templates. Okay, it's actually loading, so okay, good. So I'll come back here again, external reference drawing. Click on this and I'll check this as well. Load my file, which is in DXF, and then I open. So I'll allow that to load. Okay, so it might actually take a while, but it's definitely going to load. Okay, okay. Good. Click on OK, and then I'll come to import members. Okay, I want to import the grid that is there. I also want to import the columns that are actually there. Okay, so I'm going to click on OK. Now my direction 1 and my direction 2, it means my x-axis and then my y-axis. Okay, that is just what it means by that. So my direction 1 and direction 2, if you could remember, they are all in the layer called grid. Okay, and then that's for axis. Okay, and then for column, I actually place them in the layer called column. Okay, all these layers are actually the layers from the AutoCAD file itself. Okay, so I'm actually going to click on OK, and then I'll come down here. You can see I don't have any error. Number of errors are actually 0 on this. Okay, I close that, and then I also close this. So sometimes you may not find your drawing here, so I have to zoom. Okay, it's actually definitely going to be around here. So this is my GA. Okay, now good, you can see the columns. Okay, now you can see that the software itself has actually imported all of this column, and it has actually given it a name itself. Okay, so I have like a double column here, so I guess this is an error from the software, from the GA I imported. So I'm actually going to trace that and delete it. So this is actually very sensitive. You have to take note of all of these little errors, okay, so that it will not show you an error of overlap, okay. It might tell you column overlap, okay. So I'm going to delete all of that right now. Good. Now I have all of my columns are actually very much available here. Now the next thing I'm going to do right now is to actually, now I already have my axis. It's actually maintain the axis from the AutoCAD environment. So I have my axis. Now the next thing I will do is actually to draw my wall. This is my core wall, okay. This is where I'm going to have my lift, okay. So to do that, I'll just come to my wall. Okay, before then I'm going to insert the number of stories, insert story, and I'm going to make this 10, and I'll click OK. Good. So I'll come back to my story 1. Okay, now I'll go to my stories, and I'll right click and I'll click on edit stories. Okay, now you can see here, now this first story bottom level is actually telling you from your natural ground to your DPC. Okay, so I want it to actually be 450. Okay, so that's for your, from your natural ground, okay, to your DPC. Okay, so I'm going to leave it as 450. So the foundation depth, okay, I'm going to leave this as it is. Here I'm going to use PC, that's pile cap. Okay, so I'm going to make this pile. Okay, foundation. Okay, here you can see the height at each level is actually 3 meters, 3 meters, 3 meters. I can decide to readjust all of this, but I'm actually going to leave it just as it is. So this is an office, for example. I can name this office as well. At the 9th floor, I'm going to have the manager's office, for example. Okay, so so all of these stories, I'm going to make it similar to story 1. Okay, before then let me just, okay, assume roof as a normal story, so click on OK. Okay, now the next thing I'll do here is to actually draw my wall. Okay, so I don't know whether a shear wall or a core wall, whatever you call it. Okay, so this is 115. Okay, so this is where I want to have this, have another here. Let me just cover this. Okay, Okay, good. Now I have my core wall. The next thing I'm going to insert are my beams. Okay, so I'll come to my beam. So okay, I'm going to make this pin at this end. Okay, so I'm going to specify the size of this beam, 230. Okay, so this is going to be 300, this is 150. So in total is going to be 230 by 450. So I will make this at the center. So okay, okay, so there is no, okay, so this is actually going to be continuous here. Okay, so I can make this pin here and then pin here as well. Well, for the sake of time, I'm just going to highlight on all of these and make it a beam. Okay, okay, good. Okay, just going to make this as fast as possible. Okay, okay, good. Now I'm going to insert a simply supported beam here. Okay, good. Now let's view this in 3D. Okay, view 3D. Okay, good. Come to here. I'm coming to vertical tile. So here you see we have our 3D here we have our 2D. Okay, so the next thing I'm going to do right now is to actually insert a wall load. Okay, I'll right click, I'll go to edit beam wall load. Now make this 3.87. My wall height, make it 3 meters. My wall thickness 0.23. I would advise you to actually lay your hands on any of the reinforced concrete design book that is recommended in your country. Okay, so as for you to have a deeper insight of whatever you are going to be specifying here. Okay, so the wall units, width, the wall height, we are using a wall height of 3 meters, and then the wall thickness is actually 230. So I'm going to have an opening in the wall. So let's add an opening to this wall. The width the opening of the width. Okay, 1 2. This is also 1 2. For example, maybe you have your windows and all that. I'm just going to illustrate using the windows. You can insert for doors as well, but I'm just going to do for that of windows and make everything similar. Okay, just for the purpose of this training, I want to make it as brief as possible. Okay, to get the center of this is just for you to punch your 3830. Okay, 3830 minus 1200 is what? Okay, divided by 2. What do we have now? Good. So our value is 1315. So here on our x is 1315. Okay, so you can see now it's actually placed at the center. Now to bring this at the middle here, you subtract 900 up here, you subtract 900 up down here, and then this is actually going to be centralized. So I'm going to make this 900 for my y. Good. I'm going to click on OK, and then I'll click on OK. Now you can see that our wall has actually been created for this on top of this beam. Okay, okay, now good. The next thing I'm going to do is actually I'll copy this wall load, beam wall load, and then I'm going to paste it on all of the beams that are here. But before I do that, I'm going to turn off some of these layers. I'm going to turn off the axis. Okay, I'm going to turn off my column. Good. Now I'll turn off the wall. Okay, good. Now I'm going to copy beam wall, copy beam wall load, and then I'm going to paste it on all of the beams, and then I'll come to paste copy beam wall load. Yes. Now good. So I'm going to turn on all my layers on. Now you can see what we have here. So let's now this is the 3D. You can see, let's view this. This is what we have here. Okay, so here now the next thing I'm going to do is actually to generate all of these, assuming all of these levels are actually the same. Okay, in order to save time. Okay, so this is my story 1, so I'm actually going to generate all of this. Okay, I'm going to generate all of this to so sorry, before then I'm going to insert slabs for this. Okay, so I'll come to my slab, I'll come to slab, and then I'll make this thickness 175. Okay, okay, so my dead load. Okay, I'm going to assume my dead load is 3. For example, maybe my finishes, my partitions. Okay, I would advise you to actually lay your hands on any of those reinforced concrete design book. If you are in Nigeria, I would advise you to get reinforced concrete design book by Victor Oyenuga. Okay, this is actually a very great design book, more especially if you are in Nigeria. Okay, so here I'm going to right click. This is actually offices. Okay, so offices for general use. So So because of time, I may not go deep into explaining this dead load right now. Okay, so this is actually just an assumed value. Okay, so I'm going to insert my slab. So this is another slab, this is another slab, another slab, another slab, another slab. Good. So I have all of my slab here now. The next thing I will do is to generate all of these stories. Generate okay, so you can see it is actually highlighting story 1. It's telling you that we are presently at story 1. Okay, so I'm going to generate it all to my story 9. Okay, so I'm going to click on OK. So it's actually loading. So sorry, this part may actually take a little while, so but I guess it's actually worth the wait, right? Okay, it's actually still loading. Good. So I'll click still loading. It's actually still loading. Okay, the file is actually going to be very large. Okay, so that's the reason why it's like that. Okay, okay, close. Whoa. Okay, this is what we have. Okay, good. Now let's come to our story 9. This is what we have. So we are going to generate all of this to our story 10, but our story 10 we are not going to be having a slab. Okay, we are, I'm going to maintain it as okay. So I'm going to generate all of this. I'm going to generate this to story 10, and I'll click on OK. It's still loading. Okay, good. Now on story 10 we cannot have this wall that we have right now. Okay, so I'm actually going to take that off. So in order to do that, I'll just right click on this, because I'm actually on my story 10. So I'm going to right click and I'm going to delete beam wall load. Okay, so yes, I'm going to click on yes. Good. So this is what I'm actually going to have right now. Okay, so my beams on my roof, this is actually going to be my roof beam, so I can actually select all of the beams that are actually here and change the dimensions, for example. So what I will do here is to turn off some of these layers. I'll turn off this, turn off my color, turn off my wall, I'll turn off my slab. Good. Now I'm going to right click all of my beams, and I'll right click and I'll go to properties. Now on this property, I can decide to make this 0, 0, 0, 0. Okay. So right now I'm going to be having 230 by 300 beam, okay, for my roof beams. Okay, so here is going to be 0 as well. Good. So I'll close this. I'll turn on my layers. Okay. Okay. And then on this level, I'm going to delete this slab. Okay, or I can actually I can change the property of this slab. Okay, or I delete it. Yeah, I'm just going to leave it as it is right now. Okay. Now you can see this is actually the model. Okay, you can see this 3D model of what we are actually doing right now. Good. Now we go to building analysis. Okay, so edit material, the grade of concrete. Okay, this is characteristic strength of your concrete. Okay, this is characteristic strength of this concrete is actually 20 to 25 is actually the cube itself. Okay, so this is actually the strength of your concrete. Okay, so I'm going to leave it at this range of 25, 30. Okay, so but whichever I choose, you discover the modulus of elasticity here actually changes, and some of other data here, all of these informations, you will discover there will be a whole lot of changes there. You can see the unit weight. Okay, that's the density of concrete density. Okay, it's actually 24. Okay, so I'll click on OK. So the concrete column, so I'm going to make choice of my reinforcement. Okay, as you know, the software is actually very sensitive. Whatever choice of reinforcement you are making here will affect what is actually going to give you out. Okay, so be very careful on the selection you do here. So if you mistakenly tick on Y6, Protastructure may most likely even provide the reinforcement of Y6 for you. If you by mistake check this, it may provide a reinforcement of Y7, which you know is not available on the market. Okay, so I'm going to click on OK. If I come down to my wall, I'm going to choose Y12, Y16, Y20, 25. I'm going to leave this as it is like this. So my concrete beam, I'm going to use Y16, Y20, Y25 and Y30. Okay, my slab, I'm actually going to use just Y12. Okay, so for my links, I'm actually going to use Y10. Okay, so this part of making choice of reinforcement is very sensitive. Okay, so you must take note of this. Okay, now the characteristic strength of my steel is actually I'm going to use 460, and then I'm going to apply to all members. So the same thing here, I'm going to apply to all members, and then I'm going to click on OK. Now good. Now I'll come to my parameters here. You can see BS8110. Okay, this is actually British standard. Everything here, I'm going to leave it as it is. The allowable stress of the soil, that is the soil bearing capacity, is actually 200 as it is here by default, but this is actually from a soil report. So whatever soil report you get from the lab, okay, that is actually the value you input here, and then the soil subgrade coefficient, there's a little calculation for this as well, but then I'm actually going to leave this as it is. So the lateral loading, or let me just reduce this to, let me make this 150 for example. Okay, so the lateral drift braced, I have a core wall there, so I'm actually going to leave it as a braced. Okay, so my loading combination here, I'm going to loading generator. Okay, this is actually for the vertical loads. You can see for your vertical you have a defined dead load, you define live load, define pattern loads automatically. Come to horizontal load combinations, we have notional loading. Okay, so I'm going to check on wind load because of the height of this building. This is actually a 10-story building, so it's actually going to be very high, so we must consider wind load in this. So I'll click on OK. So my load cases, these are actually going to be different load cases, which I'm going to be showing you much more later in this video. Okay, so I'm actually going to click on OK. So I'll come to my story loads and pattern. Here you can see for all of these here, as you can see, everything here is actually showing me 0. So by the time I do my analysis, you're going to see values on some of these, and then some of these values I'm going to do the calculation manually and then show you how to input all of those values on this. Okay, so I can expand our story so as for us to see all of this. So I'm actually going to click on OK. I'll go to my analysis. So I'm going to analyze this building. So I'm going to allow this to finish loading. Okay, still loading. So if you love what you're seeing, make sure you like this video, please give it a thumbs up. Subscribe to this channel, is 100% free. Just click on that red button down below this video. Just look for it, you'll find it. You'll see it is written subscribe. Just click on it and you have subscribed already. Okay, click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly basis, sometimes even on a daily, so as to encourage as many that want to have a deeper insight of design. Okay, make sure you come register with us. We'll guide you through the process of design until you attain mastery. Okay, for a token of 12,000 naira. We'll guide you through the whole process of design using all the listed softwares there. Here I'm going to click on OK. You can see it has checked this good, showing me that my design is perfectly okay. Okay, so we'll come to all of these post-processing, model, and all this later on in this video. So make sure you stay till the end of this video. Okay, so right now the first thing I'm going to do is to, you can see our, okay, let's come back to our building analysis. I just want to show you something on this. If we click on this, you can see the value of our nx ny is no longer 0 as it was in the initial. You can see some of these values, we're able to get some values in it. Okay, good. Now the next thing I'm going to do is to actually do some of this calculation for our wind load, okay, which I'm going to be imputing right away. Let's jump right into that. Okay, so if you get a reinforced concrete design handbook, okay, by Charles E. Reynolds, okay, if you go down to page 137, you can see the characteristics wind pressure. It's actually WK 0.613 VS square, Newton per meter square, where your VS is actually the design wind speed in meter per seconds. Okay, so in Nigeria, our design wind speed actually falls, I think the maximum is actually 9.5, which is in areas like in the far north, where you have a very high where you have desert areas. Okay, so in this design I'm actually going to be using 9.5. okay, so our VS that I'm going to be, our V, okay, S is actually going to be, sorry, our basic wind speed rather, sorry, I don't mean VS, I mean my V, which is the basic wind speed, is actually going to be, I'm going to be using an assumed value of 9.5, assuming this structure is actually going to be designed or is actually proposed to be in the north. Okay, now good, you can see the S1, which is multiplying factor relating to topology. Okay, S2 is the multiplying factor relating to height above ground and wind breaking. Okay, so our multiplying factor is actually for S1, and my S3 is actually going to be 1. Okay, so let's come down and explain this further. You can see S1 may generally always be taken as unity except in the following cases. So except in the case where on site we have adversely affected by very exposed high slopes and crests where wind acceleration is known to occur. Okay, on site in enclosed steep-sided valleys completely sheltered from winds. Okay, you use, so in a case where you have a very critical case, you use 1.1. In a case where you have it is completely sheltered, okay, like an urban area, okay, so in that case you use 0.9, but for this design I'm actually going to be using 1. Okay, so S1 is a probability factor relating the likelihood of the design wind speed being exceeded, okay, to the probable life of the structure. A value of unity is recommended for general use and correspond to an excessive speed occurring once in 50 years. So this is actually a return period of 1 in 50 years. So our design is actually going to be within this range of it is actually not greater than 50 meters. Okay, so if your building is actually not greater than 50 meters, this is definitely where we are going to be using. Okay, it's definitely, there will be no cladding on this, so this is what we are going to be using. Our building is actually not higher than 50 meters, where we can check from here. If you come to your story, edit prop story, okay, you can see it is 30 meters 450. Okay, so 30.45 is actually the height of this building entirely. Now we'll come back here. So if you come down here, you can see open country with no obstructions. Okay, so there is no obstruction. Open country with scattered wind breaks. Country with many wind breaks. Small towns, suburbs of large cities. So so I'm going to use open country with no obstruction, okay, because we have very few number of high-rise buildings, most especially over in the north. Okay, so in that case, sorry, I'm just going to assume this to be number 1. Okay, where I'm going to be use all my values are actually going to be within this range here. Okay, so let's go into that right now. So I'll come to my Excel in order to make this work easier and faster for me. So the first thing I'll do here is actually to make this story. Okay, okay, so I'll name this I'll name here height. Okay, height. So 1, 2, 3. So I have up to 10 of this. So here I have 3. each of them 3 meters height. So sorry, it's a mistake. So I have 3 here. So there's going to be 6. Okay. Let me do some little calculation here. So this is actually going to be B2 plus 3. Okay, and good. So the next thing I'll do here is to name this my S1, name this S2, and I'll name this S3. Okay, so for my S1 it's actually going to be 1, so I assume value of 1, so I'll use it for all here. For my X3, I assume it's 1. Okay, so for my S2, I'm going to pick that from the chart here. So you can see for the story height of 3, for story height of 3, so I'm going to actually make this as fast as possible, okay, because of time. Okay, you can see here for this just a table, you can see of height of structure. Okay, so for within the range of 5 meters is 0.83, within the range of 10 meters is 0.95. Okay, so I'm actually going to make this as fast as possible. So so let's come back to my chart here. 0.83, 0. Okay, 0.83, 0.95, 0.95. Okay, 0.99. Let's check for 19. Okay, range of 21.1.1. Okay, 0 1 1.01. Okay, I think that is what we have here. Okay, good. Well, this is just an example. So for my VX, my WK, okay, open bracket, and divide square close the bracket. Okay, so my VX, sorry, so I have my VS square. Now I'm picking all of these formulas from here, please, so that you don't get confused. This is my S1, S2, S3, this is my V, this is my VS. Okay, so here for this you can see it is actually 0.613, okay, multiplied by Vx squared, okay, which is in Newton per meter square. So in order to get WK, we'll have to get our VS squared. Okay, so that is where all this is coming from. Good. So to get my VS, so what is VS? My VS is actually V multiplied by S1 multiplied by S2 multiplied by S3. So that is for my VS. So to get my VS, I will say equals to okay, my V, okay, sorry, I don't think I've gotten the value for, okay, my V, sorry, my V, I said I'm going to be using, so I'm going to move all of this, cut, so I'm going to make this V. Okay, sorry about that. My V, I said our wind speed in Nigeria, it's actually, I think the highest is 9.5. okay, so I think it's within the range of 2.5 to 9.5. You have to consult your reinforced concrete design book to confirm what I'm saying. So it falls within that range. So 9.5 is the maximum, which is within the northern far north in Nigeria. So I'm actually going to be using 9.5, assuming this design is going to be in a place like maybe Kebbi State, or let's say Kebbi, let's say Sokoto. Okay, so if that is correct, what I will do here is to actually make this V to be 9.5. okay, so I'm going to copy that for all here. Good. So to get the value of VS, our VS is actually equals to V multiplied by S1 multiplied by S2 multiplied by S3. So in order to do that, I will just come here and I'll type my equal to, okay, V times my S1 times my S2 times my S3. So I'll click on enter. Now I'll drag this. Good. Okay, I think there is a mistake here. We have 10 story. Okay. Good. Good. So for 30, what do we have for 30 here? 1.05. 1.05. Okay. Okay, good. So this is actually going to be VS squared. Okay, so to do that, I'll type enter my V, okay, raised to the power of 2, and I click on enter. Good. Now for my VK, which is actually 0.613, okay, which is 0.613, okay, times our Vx squared. Okay, so to do that, I'll just type in my enter. 0.613 times my V squared, okay, and I press enter. So this is what I have. So what do I have here? 0.613 squared. So drag this, now drop. So this is WK into brackets kilonewton. This is actually newton per meter square, so I'm actually going to convert that to kilonewton per meter squared. So in order to do that, 1000 newton actually makes 1 kilonewton. So what I will do here is to divide this value, divide by 1000. So what do I have? Good. So I drag this. So the next thing here is to have my horizontal direction and my vertical direction. So so I'm going to make this horizontal, so before then let me just this too. Okay, so I'm going to name this horizontal direction. Okay, so I'm going to make this vertical direction. Okay, so for my horizontal direction, I have to come back to my AutoCAD drawing. Let me show you that from there. AutoCAD file. Good. Look at it. Now Okay, now look at this here. Sorry, it's actually loaded. Okay, so it's actually still going to come up. Okay, okay, it's loading. Okay, good. Now you can see for my, this is my horizontal direction, this is my vertical direction. So for my horizontal direction, let me check the dimension of this building. What is the total length? Okay, you can see it's 11.72. So let me check for this. Okay, which is 8.6191, 8.691. Okay, let me check it from here. Sorry. Okay, let me use this value. Let me make use of this value. Sorry, I just don't want to. Okay, so I'm going to use 11.49. okay, so I'll come back here for my horizontal. What do I have? 11.49. So for my horizontal, I'm going to use 11.5, for example. Okay, so approximately, I just want to make this a bit faster, so I hope you understand. If you have any challenges, let me know. Okay, so here I'm going to make this approximately 8.5. okay, so this is 8.5. So good. So I've gotten my horizontal and vertical direction. So my horizontal now divide by 2, my vertical divide by 2. Okay, so as for us to get the midpoint of this, okay, I just want to get the center of this, the center from here to here, okay, and then the center from here to here, okay. So the midpoint will definitely be at this point. So let's get that here. Okay, so our H is actually going to be our horizontal. Okay, so it's going to be equal to our horizontal divided by 2. Okay, so I have 5.75. okay, here I'm going to have equal to my vertical divided by 2. So equal to, enter. Okay, so I'll grab this here. So my center of gravity, okay, is the next thing here, which is CGX, and then I'm going to have CGY. So I'm going to have the center of gravity for my x-axis, the center of gravity for my y-axis. To get that, I'll come back to my drawing here. So I'll go to my story 1. So I'm going to make these larger, so that's so this is my center of gravity. So I'm going to measure from this center to this point. Okay, so I'll measure here. You can see if I should zoom this to this point. Okay, so you hold on your control key in order to get a straight line. Okay, so you can see it's 5.8. So I just want to show you something here. You can see it is written center of gravity. So good. So it is actually going to be equal to whatever is going to be here too as well. So if I measure from the midpoint here to the other side, so I'm going to hold on control key, hold on control in order to get a straight line. So I'll hold on that. So good. Now to get for the vertical is the same thing. All I will do is just to right click on measure. I'll click on the midpoint of that center of gravity, and I'll click hold on my control key in order to get a straight line, and then you can see this is 4.4. so our vertical is 4.4, our horizontal is 5.8. so our horizontal is 5.8, our vertical is 4.4, which is actually equal all through the floors. Okay, because we have the same shape, everything is actually the same all through the whole floors. Okay, but at the roof level we may actually have a bit different. So let's go to our story 10 and look for, okay, so I think the center of gravity here is actually still the same with what we have there, okay, on other floors. So okay, so if I hold on this, hold on control key, and then sorry, that is not actually at the point I want to hold. That you can see it's actually going a bit outside, but I'm going to maintain everything here just to save our time. Okay, but I believe you understand what I'm trying to actually explain here. Okay, now good. Now the next thing I'm going to do is actually to get the difference between the center of gravity and your midpoint. Okay, so in order to get that difference, so I'm going to have my h divided by 2 minus my center of gravity for my y. Okay, so this is going to be my h, sorry, it's going to be my v divided by 2 minus the center of gravity for my, sorry, this is for y, and this is actually for my x. Okay, so I have for my y, I have for my x. Okay, so all I will do is click on my equal to, so my h, this is my h, minus my cgx, so I might click on enter. Now I'll drag all that here. So here I'll have my equal equal to my v minus my CGY, enter. So if you do that calculation manually, you should be able to get exactly what I'm having here. Okay, good. Now the next thing here is to get my xg and my yg. Okay, so my x g, this is my y g. Okay, so this is actually gotten from our Protastructure here. I'll come down to my building analysis. Okay, I'll go to story loads. Okay, now here you have your xg and your yg. Okay, so you can see everything here is 8.93. So just these two last ones that are actually different. So I have 8.937. 8.937. Okay, good. So this last two, I have 8.935, 8.935, then here I have 9.093. okay, 9.093. So for my yg, if I come down here, I have so everything here is actually the same. So until the last one where I have 402. Okay, zero 403. I think, is that what I got? 402, sorry. Okay, good. Now the next thing here is to get my xc1 and then get my xc1 and then my xc2. So to get my xc1 is actually going to be my center of gravity for x, so it's going to be equal to my center of gravity for x, okay, plus my h2 minus cgx, okay, h over 2 minus cgx. So this is it. So my xc2 will now be my equal to my yg plus, sorry, what did I do there, plus my yg plus my v over 2 minus cgy. Okay, this is what I have. I think I actually made a mistake there. Sorry, let me delete this and take this back again. My cx is equal to my h over 2 is going to be xg plus xg plus h over 2 minus cgx. Okay, which is, I press enter. Okay, it's correct. Okay, good. So the last thing I'm going to look for is my ry here and my rx. So to get the value of ry is actually going to be equal to wk, or ry is equal to my wk times my h over 2 times 3, which is the height of the building. So this is actually times 3. Okay, well, let me just finish that and I will explain briefly. Okay, so here I'll drag this here. So the last but not the least is my rx. Okay, so I'm going to explain that briefly. So for my rx, it's actually going to be wk, which is in kilonewton per meter square. Okay, v, which is my vertical. So let me just do that here. So it's going to be wk times my v over h, which is this, times 3, which is the height. So this is what I'm going to have. Now what I was actually doing was this. If you have your length, so you have, this is actually your vertical, this is actually your horizontal. Okay, so I'm multiplying my vertical against this horizontal, so it's actually going to be at the half of this. Okay, so in case you have any challenge, any question, you can drop it at the comment box. Okay, just drop your comment. Okay, and then ask your question and I will do well to reply to your questions. Okay, so after getting all of this table, the next thing I'm going to do right now is to actually come down to my Protastructure, and then I'm going to expand all of this. Okay, so I'm going to impute all of these values one by one. Okay, so to do that right now, you can see now I have gotten the value of my rx and the value of my ry. I have gotten the value of my x and have gotten the value of my y. So at each story, you can see this is for story 1, this is for story 2 up to my story 10. Okay, so for my story 1, come back here, and the value for my rx I'll copy, and I'll paste it here. So the value for my ry I'll copy. Oh, sorry, I just did for ry. It's supposed to, sorry. So you have to be very careful with this, okay, in order not to. So this is for ry. Okay, so I'll take this off. I'll pick for rx. What the I went and copied the formula instead of supposed to copy this, okay, not the formula. So come here. So this is actually going to be a little bit time consuming, so I may not do for all. So I'm just going to illustrate this. So for my x, and this is for my y. So let me come here. So my this is actually for my x here, and these are actually together, so you don't mix it up. Okay, so I can actually just give it the color. Let me give it the red color. Okay, good. In order to actually differentiate this from, so these are actually together. Okay, let me make this blue. Okay, good. So I have noticed the difference between them. So for my my x, this is for x, for this xc1, that's your y, your x. xc2 is actually for your y. Okay, you can even see the value. It's actually very close to what we just got right now. Okay, so I've gotten the value for my rx, my ry, the value for my x, and the value for my y. Okay, so I'm actually, you do it for all the stories. I just did for story 1, so you can go on and do for story 2, story 3, story 4, up to the last story. Okay, it's just for you to copy and you paste, you copy and you paste, you keep copying and pasting until you are done with that. Okay, so okay, let me just put for my x2 for my story 2. Okay, my story 2 rx, copy, ry, good. So I'll come to my x, this is my x, sorry, I'm in story 2 right now, so you must be very careful with this not to make an error. Okay, so I think almost okay, for my x1 x almost the same all true. So I'm going to make this my x, my y, my y, so go down to story 3, my rx, my ry, so this is actually my rx, my ry is this is my ry. Okay, so I have to keep doing it for all of these stories. Okay, time may not permit me to actually go into that right now because of time, so I'm actually going to click on OK and allow this as it is like this, please. Okay, I just want to make this tutorial as brief as possible. Okay, so now you understand how to insert your wind load, okay, on, because a whole lot of questions have been coming how to insert wind loads. Okay, so this is actually how to calculate your wind load. Okay, now the next thing I'm going to do right now is to come down here and then let me go to my building analysis. So let me go for my axial load comparison report. Okay, the report is still loading. So if you love what you're seeing, make sure that you actually give it a thumbs up, subscribe to this channel, it's actually free. Click on the bell icon so as to always get a notification whenever I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Okay, sorry, I think that is still loading, please. Okay, the design is actually very large, so it may take a while for it to finish loading. Okay, okay, I've covered a very wide range of design on covet, on cantilever retaining wall, on pile cap, on pile foundation, on isolated part, on raft foundation. I have covered a very wide range of design on retrofit, on your shear wall. Okay, all they are very much available on our YouTube channel. Okay, all on our Protastructure, they are very much available on our YouTube channel. Okay, you can as well enroll with us where we'll guide you through the process of design on each of those softwares which I have listed initially. You can see 19 different packages available on our Telegram platform. We'll give you the software, guide you on how to install it and how to crack it. Okay, now this is actually the report, so I'm actually going to close this. I can go for this analysis to check model and analysis results. Okay, okay, so let me come to my column. Now you can see. Okay, I'll come to my interactive design. Okay, so here I'm going to reselect all of this and I'm going to design it. Okay, this is my analysis model result. Okay, you can see different load cases. Okay, these are the different loadings subjected to this particular building. You know, I did not finish my my wind load. Okay, so can switch this to finite elements. Let's check for the displacement. Okay, you can see go for animation. Sorry, I'll come back to my column so as to design that. Okay, you're going to see how this building is actually going to behave as well to the loadings that are actually going to be subjected to it. Okay, so it's actually loading. The design is actually very large, so is still designing this. Okay, our column, still designing our column. Okay, you can see the animation. You can see it's actually telling us this is actually how this building is definitely going to behave, okay, to each of this loading. Okay, these are different load cases. Okay, you can see this is dead load, pattern dead load 1, pattern dead load 2, life load. Okay, look at your wind load for your X, for your Y. Okay, the design is actually very large, so at your time you can actually go through this and then test for all of these loadings and see how the behavior it's actually going to look like. Okay, so our columns are actually now you can see that majority of this column have actually passed. Okay, so the columns are very much okay. Our columns are very much safe. Okay, so I'm going to close that, and then you can check for your beams too as well. Okay, so I'll come to beam design batch. Okay, I will select and calculate for this as well. Okay, it's actually loading. So here I'm going to this. Okay, so it's actually designing our beams right now. Make sure you visit my channel so as to see a whole lot of training on Protastructure that I have covered. Okay, they are very much available on that YouTube channel. You find the link down below the description of this video. The main essence of this training for this particular video is actually to show you how to actually calculate your wind loadings, because a whole lot of questions have been coming in on how to actually calculate for wind load, or how to add your wind load to your design. Okay, so it's still loading. This is actually going to take a very long time. Okay, as you can see, the beams are actually much. I have a lot of them on this design, so it's actually going to be very time consuming. So it's still at story 4, remaining up to 6 different stories. That's story 5 now. Okay, so that's story 6. Okay. Okay. Mind you, all of these softwares are very much available. So come register, we'll guide you through the process of design. Okay, we'll show you how to do some detailing like your foundation layout, column and base detailing, slab and beam layout, slab detailing, beam detailing, roof beams, concrete fascia. We cover electrical, legend, lighting points, power point, distribution board. For your mechanical service drawings, mechanical legend, water supply / AC installation layout, drainage layouts, WC detail and septic tank schedule, septic tank and sockaway. All of these I have covered, all of this training too as well. Okay, I've covered cantilever, retaining wall detailing even on AutoCAD too as well. Okay, so they are very much available on that YouTube channel as well. Okay, these are some of the social media platforms. You can follow me on any of these social media platforms. Okay, this is my email address, you can email me. Okay, this is my WhatsApp contacts. Okay, on Skype, this is Twitter, on Instagram, on LinkedIn and on Facebook. Okay, you can follow me on any of these social media platforms. It's actually very much available on the description box. Just go down below the description box, you find all of this there. Okay, so you can just register and then we'll guide you through the process of design. Okay, so while we'll allow this to keep loading. Okay, okay, so it's actually at story 8 right now. So it's at story 9. So this will actually soon be done with this. Okay, so if you like what you're seeing, make sure that you actually give it a thumbs up. Okay, make sure you subscribe to this channel. It's 100% free. Okay, make sure you click on bell icon so as to always get a notification whenever I post videos like this. Okay, I usually post videos like this on a weekly, sometimes on a daily. to encourage as many that want to have a deeper insight of design. Okay, come register with us. We'll guide you through the process of design for 40 days. We'll give you the software, guide you on how to install it, and guide you on how to crack it on your system yourself. Okay, amazing, right? So you will learn a whole lot of great things with us. Okay, so you can see all our beams have passed, so because our time has actually been far spent, so I'm actually going to leave all of this. I'm going to close this right now. So let me come back to my concrete. Let me go to my beam, story beams. Another thing here, you can change like the setting and your parameters each of this beam. Okay, you can change how your reinforcement should look like. Okay, you can see your steel pattern. Okay, you can see use for 40%. Okay, so you can change this pattern. Okay, we have different patterns here. You can see even your links. Okay, where you cut here. Okay, method. Okay, let's come here. Come to curtailment. You can see this is 0.4, that is 1/4. Divide by 4, this is what you have. Okay, so that's the distance from here to here, and you take by 4. Okay, so you can readjust all of that here in this place. Okay, so even this section here, you can see different beams. Okay, so you can remove all of your sections. You can make it at all the beams. Okay, you can actually span section only, so it's going to be 1. So a lot of great things you can actually do here. So even on each of these beam, you can edit and adjust. Just for example, maybe if any of this beam actually failed. So right now I'm going to be designing for our foundation, which I'm going to be designing for the pile cap. Okay, so I'll be taking you through that process right now. Okay, I'm going to be designing that right now. Sorry, this is actually taking much of our time. Allow it to load. The design is actually very large, so okay, good. So I'm going to close this. I'll come down to my story 0. I'll click on story 0. So my story 0. So this is actually my story 0. So what I will do here is to go to my settings, and then I will come on my settings. I'm going to foundation design settings. So you can see here we have general, we have pile cap. Okay, so because of time, you can see ultimate compression capacity. I'm going to leave almost everything at default as it is. Okay, so my pile cap, my pile. Okay, all of these values you can get some of them from your soil reports. Okay, like the ultimate compression capacity. Okay, the pile size. Okay, I'm going to make this 450, for example. My penetration. Okay, my penetration, I'm going to leave it. Okay, let me make it 250. Okay, so I'm just going to leave everything as it is like this. Okay, assuming every value as it is, just the way it is right now. You can see default pile length. Okay, this is actually going to be the length of that pile. Okay, so it depends on how deep the foundation is going to be like, and that is actually determined from your soil test. Okay, the reports that you get from the soil lab. Okay, now to make this faster, I'll just highlight on all of these columns and then insert my pile cap. Okay, sorry about that. Go back to story 0. So, sorry about that, please. Okay, sorry about that. Okay, sorry, this system is actually malfunctioning itself. Okay, because of the loading. Okay, it's actually loaded right now, so I'm going to, what am I doing? Don't worry, all road leads to Rome. Okay, I'm going to insert my pile cap. Okay, good. Now you can see this is what I have here. So I can, sorry, it's still loading. Sorry, you have to allow that to finish loading. It's still loading right now. Okay, good. Now I'm going to design all of it. Okay, still loading, so I'm going to allow that to finish loading. Okay, so we have to patiently wait for this to finish loading. Okay, okay, now that it has designed everything, you can see everything is checked green. Okay, so everything is safe. I'm going to click on OK. Okay, So from there where I just closed right now, you can actually make some adjustments there, like in terms of your reinforcement, in terms of the thickness of the pile and all that. Okay, but I didn't go into that because of my time. Okay, I didn't want to actually kind of okay. You can see the piles here we have. Okay, so here I'm going to Windows to vertical. I'm going to make one of these 3D. This is what is going on here. So sorry, because of time and because of I didn't want to go in detail adjusting each of these. Okay, so, and the design is already very large. You can see how it's actually behaving right now, but okay. So I'm going to rotate this. So on this point I'm going to actually, I need to design a foundation for this wall. Okay, so in order to do that I have to offset this. Okay, so I'll click on the axis, I right click, I offset axis. Okay, so I'll hold on Control F2 and then I type 600. Okay, so I'll click on this as well, click on this, right click, offset, F2, 600. Click on this, click on this. Oh my god. I'll click on this. Okay, I right click, I'll offset this, F2 minus 600. So the F2 is actually to help you type in the value. Okay, offset, hold on F2 minus 600 because I'm going in opposite direction. Okay, so I'll do for this now. I think the number of piles are actually much. Okay, so but I may not edit that right now because of the time. I just want to show you how to actually design for the mat for this. Okay, so I may not go into that right now. Okay, but I believe you have gotten an idea of what it is all about. Okay, so I click on this axis and then I right click, I'll set, take it to F2 600. okay, I enter, escape, right click, offset in this opposite direction. Okay, my F2 minus 600. So then this last axis here, for this axis here, so I'll right click, I'll offset, I'll make this minus 600 as well. Okay, F2 rather, minus 600, press enter. So now I'm coming to my slab / column edge line. Okay, so I'll use that to sketch my foundation part. The axes here are actually merged. Okay, so I'm actually going to reduce that here right now. I'll reduce that right now. Okay, so all I will do here is just to come to my edit, and then I will delete all unused axes in the building. Yes, good. So you can see all the axes that are not used in the building have gone off. Okay, so now I have gotten the area for, sorry, I think I made a mistake here. Take this back. Okay, I made a mistake. Okay, let me just, I'll have to draw this axis again. Okay, I'll make this F2 600, enter. Okay, the axes were too much, so I'll set F2 600. Minus 600. Hold on this. Offset. $600. Offset. Minus, okay, F2, sorry, minus 600. Hold on this. Hold on this. Click on this. Right click. Offset. F2 minus 600. Okay, the last one here. I'll come here, click on this axis, offset, F2 minus 600. So I have gotten all my axes. I'll come to slab / beam. Okay, I'll trace this. here, here, here. Oh, I think this was the same mistake I did the last time. It was the same mistake I did the last time. Okay, I have to take this gradually right now, so as for me not to make another mistake. Okay, I'm supposed to trace it like this. Okay, good, this is what I'm looking for. Now I'll come to my slab, and then I'm going to make this depth, let's say 300. Okay, and then the load, I'm just going to leave it as it is. Okay, because of time. Okay, so we insert, okay, the concrete cover, let's say 50. So I will insert the slab here right now. So after inserting this slab, after inserting the slab, the next thing I will do here is to going to take this off. Let me rotate this. Okay, so I have explained raft foundation in my design. Okay, already it's very much available on my YouTube channel, where I explained how to design your raft foundation. So if you already like what you are seeing, make sure that you like this video, give it a thumbs up. Okay, subscribe to this channel, it's 100% free. Okay, click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Okay, so after doing this, in order to get for your raft, all you need to do is just to go to your finite element raft foundation analysis. Okay, so when you go for raft foundation mesh and analysis, okay, you can see your soil subgrade coefficient. This value is actually not a constant value, okay, which I have explained on my previous tutorial on raft foundation. Okay, you can see that this thing is still actually loading. Okay, so I will allow that to finish loading. Okay, so I would not want to. Okay, yes, there have been some intersection at this point, so I know this may actually make this one close down right now, so I would not want to go into that right now. Okay, so look at the plan view. Okay, so I will not go into this right now. Our time has been far spent already. Okay, but my major concern is to get my raft. Okay, just the analysis for this raft and the design for my raft. Okay, so make sure that you actually stay blessed and make sure that you stay safe. Just visit my YouTube channel. You'll find a tutorial that covers raft foundation Here I major focus is to actually explain to you how to actually get your wind loading on your Protastructure. Okay, in a case where you have a multi-story building of up to 10 stories, or a high story building as this. Okay, make sure that you stay blessed. Thank you.